Hello everyone, I am really excited about this video. I've been planning it for a while and I kept just adding to it as I was doing more and more research, particularly because I was using deep research to make it better and better. So let's dive right in. I have talked about the concept of the automation cliff for a while, and I didn't come up with this idea. So what I wanted to do was actually share some of my personal experience, but also some research as well as some projections based on the automation cliff. Now, basically, this is the idea of the automation cliff. And we're going to unpack this, but just keep this graph in mind where you've got this stair step versus this more kind of catastrophic plunge. The TLDR is that if you focus on incremental improvements in technology, you'll end up with this kind of gradual stair step improvement of level of automation versus level of human involvement. So before automation, human involvement is high, and then level of automation. So you can think of this as similar to like Tesla's levels of FSD, because right now they're at like level 3. But ideally, full self-driving, like true self-driving, is going to be level 5, which is zero human involvement needed ever. Whereas level 3 is 99% of the time it can work, but it can't handle edge cases and does still require human intervention. I don't know the exact definition of FSD level 3, but you get the idea. So right now, most industries are using this stair-step approach, and we'll talk about why this is. But in an ideal world, and in also some cases, you end up with more of this kind of edifice approach, where you just have this escarpment that you just go careening off of, hence the thumbnail that you saw for this. All right, moving on. So what is the automation cliff? Basically, the principle of the automation cliff says that what you should do is wait until you have the full process automated end to end, and then just full send. Just send it off, and there you go. One of the key principles here is tasks should be controlled completely by either humans or completely by automation systems with no middle ground. Personally, as an automation engineer in my past life, this is what I would have advocated for. And the reason is because, it does nothing until you turn it on and you do all the full testing, and then you turn it on and it automates everything all at once. That's what I mean by the automation cliff. Now, there's lots and lots of other principles and reasons, but there's also like some problems with getting there. So let's start to unpack that in just a moment. But what I want to talk about is drop-in technologies. So let me go back a couple slides and show you what happens. So when you have an automation cliff like this usually happens when you have what's called a drop-in technology. And a drop-in technology basically means, here's the old-fashioned way of doing things where it's 100% humans in the loop, and then you have this brand new technology that means you don't need humans in the loop at all whatsoever. So let's give you a couple of examples about drop-in technologies. Now, in some cases, these are not automations, but these are technologies that could just come in and completely change everything. So first was USB. Everyone is familiar with USB. When I was little, and people my age and people older were younger, you had serials and you had parallels and you had all kinds of different connections. Now everything is USB, Universal Serial Bus. Cloud integration, so SaaS, software as a service, is another example of where you can just switch between softwares. And if you get, actually chatbots are a prime example. You can go sign up for Claude, you can sign up for ChatGPT, you can sign up for Gemini, and most of them are pretty interchangeable. So those are examples of drop-in technologies or fungible technologies. GPS was another thing that once it was there, it was ubiquitous, and now you can use it for all kinds of stuff. It enabled Google Maps, and your Fitbit and everything. There's all kinds of different cascading effects. Smart retrofitting of buildings and other infrastructure. So an example of a drop-in technology was dial-up modems, which that's probably honestly the best example, because you started with existing phone lines and then you said, well, let's make them digital, so then you can just have modems call each other and exchange information that way. And that was really kind of most people's first experience of the internet. And then we did the same thing with cable. Cable modems were just using the fatter bandwidth that the digital cable had available. And then streaming media is another example. You can swap between Netflix and Disney and all those other things. So these are examples of drop-in technologies that once you have enough infrastructure, you can just put in a new technology and you can adopt it very quickly. Personally, on an individual consumer level, you can adopt it almost instantly overnight. Some of these technologies do take longer for larger organizations to adopt, just because there's a lot of inertia in those organizations. So these are a few examples of the fact that we have had drop-in technologies that allowed for that almost saltatory leap, that very square wave of adoption. Not all of it goes that way. So before we get a little bit further, I want to talk also about examples of where full automation does tend to be superior. So if you can achieve full automation, if you can achieve that full automation cliff, that is going to be more desirable. So one example is autopilots. So originally, autopilots would basically just maintain your altitude and speed and a little bit more. But now, as airplanes are more and more sophisticated, autopilots, basically, there are stories of pilots just going to sleep with the autopilot on, meaning that they run 100% of the aircraft. Another example is pharmaceutical production. So these, by the way, these are all numbers that were surfaced using deep research. So yeah, maybe I should start including the links to those deep research articles as evidence. Anyways, let me know what you think in the comments. So having supported and worked with and consulted for and talked to people in the pharmaceuticals industry, the pharmaceutical industry is one of the most heavily automated industries out there, particularly with the actual production of drugs. And when you look at when we talk about lights out manufacturing basically means no humans need to be present or even observing. And so that took the defect rate from 0.1% to 0.001%. So in other words, keeping human supervisors was actually a net negative. It was actually better to get humans completely out of the loop. Here's another example is automated harvesters. So John Deere, so these are like the big combines that you see, like that, go over fields and harvest everything. Their fully autonomous combines reduced yield loss from 15% to 2.3% by eliminating operator fatigue and operator errors. Basically, humans make mistakes, and if you're driving a tractor for 10 hours a day, you get kind of bored, so on and so forth. You get the idea. We don't need to go through every single example, but these are between autopilots, pharmaceutical manufacturing, and harvesting, you can see that there are several examples across several different domains where full automation is actually preferable if you can achieve it. So, moving on. Now, one question you might be wondering is like, okay, well, why? Why is the automation cliff preferable if you could just gradually implement things? Number one is the performance degradation of handoffs. So, you see videos of people, driving their Tesla and it's like, oh, you're distracted and then you have to intervene. That's one example. Now, what I will say is, as a counterexample to that, is that splitting your cognitive attention with using tools like deep research. It's like, oh, here, go do a research topic for me briefly, and then I'll come back in 5 minutes. And that actually gives your brain a chance to rest. There's actually a brief story that I have where at a software company I worked at, 2011, 2012. So that was a long time ago. I built out their virtual infrastructure, and we built more build servers for them. And their build process went from 24 hours to 2 hours. And they were like, Dave, can you take those servers out? They were kind of joking, but they're like, can you remove those servers because we now have less time to actually work on our after action reports. We're used to the build process taking 24 hours, so then we have a full day to keep working. I was like, I'm not going to do that. Like, you wanted me to make things faster. I made things faster by a factor of 12. Deal with it. So anyways, you have trust issues, workload problems. Monitoring partial automation can increase the cognitive load, which that's particularly true if you're monitoring different automation stations. So that can, and if information is coming at you faster, that will tire you out much more quickly, and those sorts of things. So in many cases, if it is possible, then you want to use the full automation cliff. You want to go straight from the current way of doing things to the new way of doing things without much interstitial time. Another reason is because you don't want to keep reinventing the wheel. That was something that I didn't include in this slide, but basically every time you have to reinvent the infrastructure or implement new infrastructure that handles, human affordances and partial automation, and then you have to do it again to get to full automation, often it's better to just wait and then implement the full automation all at once. And so this is talking a little bit more, this slide we'll talk a little bit more about how In reality, usually full automation is just not an option. So this is one of the things that we're going to be talking about with the rise of agents and robots. So also my dog is under the desk. So if I seem distracted, I'm petting my dog. She'll make a guest appearance one day. So first and foremost is the economic barriers. So full end-to-end automation can often be very expensive. And as many of you have pointed out in the comments and on Twitter and other places, the first 90% is usually actually really easy. It's the last mile of automation that is really hard. And that's where 90 to 99% of your automation effort will go into is, what was it? One of you said something like, when in the space of automation, you realize that everything is edge cases. And that's not a bad way of thinking about it, is because yes, 90 to 99% of what you're doing is routine, robust, or not robust, routine, or brain dead simple. I don't know what word I was thinking of, but it's very repetitive. Maybe that's the word I was thinking of. It's routine and repetitive, but then you do need that level of high level adaptation for every single exception, every single edge case, and those sorts of things. And that is the technical complexity, where it's like some things it's just too complex to automate unless or until you get to a general purpose, general intelligence, whether it's a computer using agent or a robot, which is going to be more cognitively flexible than a human. Then the technical complexity is no longer a barrier. That has honestly been the biggest barrier to automation up to this point. But with the rise of generative AI, language models, and cognitive architectures, that's no longer going to be a barrier. Risk management, resource constraints, you can imagine how all of these things play out. But really, it's the economics and the technical complexity are the two biggest barriers or constraints to full automation. But as robots, become more ubiquitous and become more intelligent, and as computer using agents also become more ubiquitous, more robust, and more intelligent, those barriers are going to disappear very quickly. So speaking of barriers and adoption rates, one of the things that I have been pointing out to people is that technology adoption rates have been accelerating. So the automobile took a long time to reach a point of saturation. Oh, and by the way, this graph is a little bit dated because, the internet has been around for more than 10 years now. So the data in this graph is a little bit dated, but you get the point, where the television, once it got cheap enough, it took off really fast. Electricity took off really fast. But these are things that took, decades to a century to get fully adopted. But then mobile phones, PCs, internet, everything is getting adopted much, much faster. Here you're talking about adoption curves that are measured in the 10 to 20 years. Now that the internet has reached a certain level of saturation, anything that can be delivered on the internet gets adopted much, much faster. And that includes artificial intelligence, such as chatbots and those sorts of things. Robots require a lot of infrastructure to be built out. Then you have to ship the robots and those sorts of things. So because there's a physical layer to the robots, there's going to be a little bit more friction. But on the other hand, robots that are in humanoid shape are a perfect drop-in technology. So before we move on, I want to point out my my Linktree real quick, which has my Substack. It's got my Patreon, my school community. This is my learning community. I update 2 to 3 lessons per week over there. On Patreon, we have an exclusive Discord. I'm also on Substack, Twitter. I also just added my SoundCloud to my Linktree, which is where I put all my AI-generated music. It's not for everyone, but I listen to my own music a lot. So if you're into psychedelic space rock, I've got a lot of it up there. Also, I'm on GitHub and Spotify and a few other things, so go check it out. All right, back to the show. Now, what this slide is talking about, like, where are we actually trying to automate things? So what I did was I had deep research say, go find the problems that people are trying to automate today, right now, with generative AI and robotics. So here are the examples that it came up with. Number one is contact centers. So we've all by now probably heard some of the stories where call centers have had some of their staffing reduced by 90%. There's also been some stories of they've had to rehire some humans for all those edge cases that we were talking about. But at the same time, a lot of those call centers that have switched to fully or mostly AI, the CSAT scores also go up, and CSAT is customer satisfaction. So that's MBA jargon for how happy are your customers. In many cases, if you go to full automation, the customers get happier because then the quality of their service goes up and they have more faith in your service or your company or your product. So, however, with that being said, if a call center can only get rid of 90% of its people, but it still needs 10 for those edge cases, that's not full automation. And furthermore, there's plenty of other kinds of call centers that you just cannot fully automate away yet. That is still a very high target because that's what we would call low-hanging fruit. Another example is retail checkout. For instance, if you've ever gone to those self-checkouts, sometimes they break, or so on and so forth. Sometimes theft also goes up because it's like you have a self-checkout, but then you have like a human supervising, but the human gets bored and stuff still gets stolen and yada, yada, yada. So then you need more computer vision for the security and yada. And so you end up with all these other what about kinds of things that make full automation of the checkout a little bit harder. Warehouse robotics. This is another example. So you've probably seen some of the videos of like the Amazon robots where it's like Amazon has warehouses that are not human navigable anymore. At the same time, sometimes those systems still get gummed up because of complex emergent behavior that happens when you have hundreds and hundreds of item fetching robots and they get all jammed up. I don't mean physically jammed up. I mean like the traffic gets congested, and so on and so forth. So these are current challenges that we have not yet solved. And it's like, okay, well, if we can't fully automate call centers and retail checkout and warehouses, then clearly like a lot of jobs are still safe. However, keep in mind that as robots get more intelligent, every step of intelligence that they gain, and this also includes computer using agents, that dramatically expands what they can do without human intervention. So you're going to see some of these leaps, some of these sigmoid curves or these step functions where you're going to have new abilities that are going to just say, oh, all that stuff that we couldn't automate a year ago, we can automate all of it now. And I have seen that personally back in my corporate days. I've also seen it in some of the clients that I've consulted for where there are things that you can automate today that a lot of people don't even believe that you can automate. And that's one of the reasons that I make these videos is to say, hey, the thing that you think that you can't automate, maybe you actually can. So moving on. Now I've talked about humanoid robots on this channel quite a bit, but I want to talk about how this is really the ultimate drop-in solution. So one of the key things is that humanoid robots can operate in human spaces using human tools, human vehicles, and pretty much everything else. So if you have a human robot that is as smart as, or honestly, if you put GPT-4 or GPT-5 in it, or Claude 4, whatever model comes out, then it's going to be smarter than the vast majority of humans already. Then if you have watched the Boston Dynamics videos where those robots are far more agile than humans, they can do standing backflips. I cannot do a standing backflip. So they're stronger, they're smarter, they're faster, they're going to have more dexterity than humans. That means that it is a perfect drop-in solution, which means that basically any job that a human does with their hands and eyes and body, hit the microphone, these robots will be able to do very soon. And that general purpose form function means that it can even sit in front of a computer and use a keyboard and mouse if it needs to. But we can use computer using agents for that, so you can just remove the whole robot entirely. So this represents a full automation solution, and this is what I mean by the automation cliff. Once you start shipping, super intelligent, super strong, super dexterous, super agile robots, it's like game over for 90% of human jobs. Next is the computer using agents. So the computer using agents are what you've seen like Operator and Replit and all those other different tools out there. What you need to think of, and I still have people saying, Dave, why don't we just focus on APIs? And so for those that aren't familiar, an API is an application programming interface, which is basically allows one computer program to call and talk directly to another computer program without any other user interface. But keyboard video mouse, KVM, is the universal API. Furthermore, think about how the vast majority of what humans do. Also, my dogs are wrestling in the background, so if you do hear that, I apologize. So the vast majority of human knowledge work is done with KVM, keyboard video mouse. If you can do it with KVM and an operator can do it with KVM, that's a universal UI. That's a universal interface that you don't need any other infrastructure for. You don't need custom APIs. You don't need custom API discoveries. That is the API. The KVM is the universal API. And so what that means is that instead of even having a robot using the computer, you just drop that agent onto any computer or servers, and they can be virtual servers, by the way, and you have literally the equivalent of hundreds, thousands, millions of employees all using, their own laptop screen basically, but on a virtual server in the cloud somewhere. That's really what we're heading towards. And the rollout of this, so this ties back to that, what I said about, the adoption of cloud services. It's going over the internet, so that means it's really, really fast to roll out. Now, here's my personal timeline. So this is the Automation Wave optimistic timeline, and this is based on the kind of 7-year time horizon. And the 7 years is basically about how long it took for companies to adopt virtualization, which was my area of specialty, as well as cloud software or software as a service, which was adjacent to what I was doing. And when you think that computer using agents are basically virtualization and cloud software, and it took 7 years to adopt those, then we're looking at about 7 years for full commercial adoption from this year, because this year is when we're first deploying agents. So initial launch is 2025. Computer using agents begin deployment and digital knowledge work, and humanoid robots are being ramped up this year as well. Mass adoption happens 2026 and 2027. So this is when Fortune 500 companies are going to really start using both computer using agents and humanoid robots en masse. There are Fortune 500 companies already using Tesla Optimus and other robots. Just want to point that out. I think BMW was the first car company that started using them, other than Tesla, of course. So that's the early mass adoption, and then you're going to have full integration happening in 2028 to 2030. And then you're going to have the final laggards, the optimization happening in the 2031 to 2032 range. And then by 2033, you're going to have offices full of robots and computer using agents and all that fun stuff. That's my personal prediction, is that we're looking at 7 years until, knowledge work as we know it is over and done with in every industry. Now, I want to use this graph. So this graph is the adoption curve. So this is like a very similar version to the other adoption curve that I showed you. So this is a linear adoption curve, which is just at what point does a technology become saturated. But another way to look at the adoption curve is this, which is at what point does each type of company adopt it. So right now, or I guess 2024 and earlier, were the innovators. So these are all the people that, watched my YouTube channel since 2022, 2023. These are the people that have been experimenting with cognitive architectures and agents since, before ChatGPT came out, or when ChatGPT first came out. Think about back to the era of baby AGI and those sorts of things. That was the innovators. So that was the bleeding edge innovators. That was the first 2.5%. This year and 2026 are going to be the early adopters. So this is where all the first movers are saying, okay, there's actual commercial value here, let's pull the trigger. Then 2027 to 2028 is going to be the early majority. This is where, your mom and pop shops, maybe not, your bakery, but what I mean is, your average run-of-the-mill companies are going to start adopting some of these technologies. I know lawyers and law firms that are already using some of these AI tools, but they're still kind of the early adopters. So then the majority of law firms and doctors' offices and those sorts of things will start adopting then, and then you'll have the group of people in the late majority. So these are the more skeptics. These are the more brick and mortar kind of stores. So I would imagine that like Home Depot, they'll probably be a little bit later to adopt these, just because that business model hasn't changed in more than a century. It's like you have hardware and tools, and you sell hardwares and tools to real people in front of you. So some businesses, some industries are going to be a little bit more resistant to it, rather than people that are going to be more on the front end. Now, heavy industries like mining and construction, they will probably be in the early majority, if I had to guess, just because human labor is really expensive, and loss of life and injury is also really expensive. But if a robot gets crushed under a rock fall, that's just our tax write-off. You can't write off human lives. Sorry, that's not how it works. And then 2030 plus, this is going to be as the rest of the world catches up. So this is my preferred timeline. Now, I asked Deep Research to take all of this into account and make its own timeline, and it gave a much more conservative timeline. So its timeline, based on historical evidence and those longer adoption curves, which we saw earlier, says that the initial wave will be 2025 to 2030. So I need to emphasize this is not my personal timeline. I'm just showing you what the AI said as a more conservative or realistic timeline. So 2025 to 2030, this is when we're going to see digital knowledge work get replaced. The early majority won't be till 2030 to 2035. Again, I don't believe that. Service integration. So this is where you start to see kind of the early and late majority. So some of the more resistive industries. So like healthcare is a very resistant industry. Education, very resistant industry. It doesn't expect that we're going to see full automation there for the next 10 to 15 years. Again, this will not age well. And then by then, there will be enough regulatory pressure on states and federal governments to say, okay, we need to do things differently. And that's 15 to 20 years out. Now, keep in mind that 2045 is like singularity. So if teachers' unions are still preventing AI in the classroom when singularity hits, oh boy, are they in for a rude awakening. Anyways, like I said, this timeline is way too conservative for me, but I felt like just for the sake of argument, I had to put this is what the AI thinks the timeline is going to be. Now, what I do predict is that as computer using agents and robots ramp up in terms of intelligence and ubiquity, we are going to see total workforce automation as we understand it today. Now, we can talk about post-labor economics. There will be some kinds of jobs like influencers, I hope, will stick around. Entertainers will probably stick around, like musicians and stuff. There might be entirely new classes of jobs. There probably will, but the vast majority of economic activity will not be done by humans in the near future. So you look at medical precision, superhuman surgical robots with perfect steady hands or multiple hands, combined with computer using agents that are constantly researching the best medical procedures. You will not have a human doctor. You will not want a human doctor in this potential world. Next is construction. A lot of people say, oh, well, I'm a boilermaker or I'm a welder and yada, 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 and my job's safe. No, it isn't. Consider that industrial robots already do better precision welds than humans do. The only difference between like those factory line welders and a human welder is that the human is in a form factor that is more mobile. That's not an advantage in the long run. Electricians, plumbers, construction workers, welders, you guys, like, you're on notice. I'm telling you. I'm trying to warn you ahead of time that job is probably going away. Next is emergency response. So this is everything from emergency medical technicians to firefighters to even police. Or whatever, like all kinds of emergency responders. You take the human out of the loop. You have machines that are immune to smoke, heat, biological, radiological, chemical attacks, whatever. Like, there was a movie called Surrogates, which was a really cool movie. It didn't make that much at the box office, but it's a Bruce Willis movie. And one of the scenes in that movie was really cool, where there's like a bunch of soldiers and they're like all kids, like playing VR, but they're piloting little humanoid robots across a battlefield. And it's just like, robot gets, nuked and, the person's like, oh, darn. And they, spawn up into another robot. And to them, it's just a game. Science and engineering. That, I don't think I have to really sell this for my audience because you guys are like paying attention to the cutting edge of like AlphaFold and all that fun stuff. But, we have like somewhere between 8 and 25 million scientists, PhDs, or doctorates globally right now. We're going to have the equivalent of billions or trillions here real soon. And so therefore, the vast majority of scientific research will be automated. You combine those computer using agents, those digital agents, or those narrow AIs with robots, and you won't even need humans in the loop if you don't want it. Now, obviously, you still want humans saying, hey, hey, Mr. Robot, maybe stop making VX gas. We don't want you to make that because that's really dangerous for us, but you get the idea. And then finally, government. Particularly if AI is provisioned of the people, for the people, and by the people, and the AI is directly accountable to the people, then what role does elected politicians play anymore? I don't know. So anyways, thanks for watching. I hope you got a lot out of this. Cheers.